That out before we start. This is the day 4. It's section 1.4 notes. It's basically rewriting equations. So it's solving for, instead of a number, solving for a variable when we have a bunch of variables in there. So just practicing our manipulation of algebra. So these pretty much are just a bunch of problems. So all I want you to do is solve for a certain variable. So the first one I'm going to say is negative 5x plus 3y is equal to negative 4, and I want to solve for, I'll put a semicolon, I want you to solve for the variable x. So I want a thing that says x equals. Well, in order to do that, you have to isolate your variable. So we want this to stay by itself for now. So to get rid of the thing attached, we subtract 3y. So we get negative 5x equals, because these cancel, negative 4 minus 3y. And then finally, to get x by itself, we have to divide by a negative 5. Now, with this one here, since you have negatives and negatives, you can turn everything into positive. There's two acceptable answers. But this is more acceptable. X equals, this is now a positive 4 plus 3y all over 5. That is the most acceptable answer. We have solved for x, and we have isolated that variable. Okay. Other things that would be acceptable, if you wanted to, this is the same thing. You can split apart the fractions, but why even do that extra step? But I just wanted you to know that these are the same things, these two. So, number 2. That's all we're doing today. So number 2. So as I write these, maybe you want to pause it and try it yourself. I equals PRT. And the thing I want to solve for is R. Well, this one's actually a very easy one. I want to isolate R. The only thing that's happening is that P and T are being multiplied to R. So I can divide both sides by PT. If I divide this side by PT, these go away. And then I'm left with R, which is what's left over there, is equal to I over PT. And that's it. So all we're doing is manipulating. That's it. A very common one that you will see, let's do number 3 right here. P is equal to 2L plus 2w, and I want you to solve for w. Okay, so again, when there's a plus or a minus, you have to get rid of, we want to solve for this, so we need to get rid of this. Alright, and in order to do it, we have to subtract it away because they're attached by addition. So I can say P minus 2L is equal to 2w. And then finally, we have to get w by itself, so we'll divide everything by 2. And I can rewrite this as w is equal to P minus 2L over 2. Now, if for some reason there were numbers here that could both be divided by 2, I would want you to simplify that. But since the 2 cannot be, the P can't be divided by 2, you can leave it as this fraction. Okay. We're only doing like 7 or 8 of these, so we're almost halfway there. Again, pause it if you need to see it, rewind it if you need to see it again. Let's go to number 4. Number 4. I have V is equal to pi r squared h. And these are all kind of formulas you've seen probably in geometry. Just like the P equals 2L 2W, that's the perimeter of a rectangle. So, I want to solve for h. Again, this is pretty easy. We have a constant, pretend that's just like a number, and then r squared. We don't want the pi or the r squared, and it's all being multiplied together, so I'm just going to divide. So my final answer is h is equal to v over pi r squared, and that's all I want for this one. Now, this is where it gets a little trickier. Number 5. Now, again, because we're dealing with formulas, that have generally real value, non-negative values. Usually when you're dealing with area, like a surface area of this is a surface area of a sphere, the radius or the area are not going to be negative. So the only reason why I mentioned that is when we solve for this, we're going to solve for r. So let's see what happens. First, get r by itself. We have to get rid of this 4 pi first, and since it's being multiplied to the r squared, we have to divide it. Okay, so I have a over 4 pi is equal to r squared. Now, if you guys remember correctly, to undo a square, you have to take the square root of both sides. This is where it's tricky, though. When you take the square root of both sides, you get the square root of a over the square root of 4 and the square root of pi. You could put it to all three of them or have it under the same one. I'm leaving it separate for a reason. Equals r. Now, normally when you take the square root of something, you want to do plus or minus because there could be two possible answers. However, with these formulas, I only want the positive because we're dealing with formulas, and that's how I'm going to grade it on the test, so you don't have to put plus or minus. Although, if it was a general problem, you would need the plus or minus. Alright, so we're almost done, but there's a problem. This is not simplified to my liking. If you write it as square root of a over 2 square root of pi, we still have a problem. There is a square root on the bottom, and you guys will get to know that we never, ever, ever like to have square roots on the bottom. Okay, so we need to rationalize the denominator, so let's do that. And if you guys remember from algebra, to get rid of a square root on the bottom, you have to multiply by another square root of that same thing. But you have to do that on top too, because you can't change this whole thing. And multiplying the top and bottom by square root of pi is, in essence, this is 1, so you're not changing anything. So when you do that, these can combine, and these become, when you multiply the square root of something by the square root of itself, it just becomes that number. So r is equal to the square root of a pi all over 2 pi. That would be the final answer for number 5. Really know how to do that? That's a good one. That's a tricky one. If you understand that, that's great. I can do a couple more with you guys in class like that if you want, and talk about them. Alright, we got a couple more. 6. Let's do a little bit of a word problem. You have a swimming pool. So swimming pool. That's an equilateral triangle. Okay. And then it says the border is 27 feet. Express the area in terms of height. So this one you have to kind of think, okay, I have a word problem, I don't have a drawing, we need to draw something. Let's draw a triangle. Let's draw an equilateral triangle since that's what we need. First things first, if the border is 27 and it's an equilateral triangle, hopefully you guys remember from geometry last year that means that you have all three sides the same. You quickly should come to the conclusion that these are all 9 feet. And then we only have one part left that we need to deal with. We need to know h. But actually we don't need to know h because we can just call this h. And it says express area in terms of height. So that means that we don't actually need a number for height, we just need to come up with an expression, an equation here to express it. So I know the formula for area is 1/2 base times height. Okay, so I'm going to put in what I know. The base is 9 feet, and the height is what we want to just express it in. So my final answer is actually a equals 9/2. And I really like fractions, by the way. I know that's 4.5, and I wouldn't take off 4.5 in this case, but sometimes you guys turn fractions into decimals and start rounding them. I want exact answer, and exact answer is a fraction. A equals 9/2 h. And that's all I would require from that problem. Okay, now we have one more problem. This one's a trickier one. I'm going to skip a page here because I want more room. Again, you could always pause and go back, look at the problems. Number 7, I have a height of an equilateral triangle is given as h is equal to the square root of 3 over 2 times the base length. I want the area, so express the area in terms of the height only. So I know again that a equals 1/2 base times height. I only want height in my problem. So that means I have to get rid of this b. Well, that means I have to substitute something in for that b. Well, I have to look over here. Do I know what b is yet from this? Well, you should hopefully say no. We know what h is, but we need to solve for b. So this is actually a two-step problem. I have to take this equation and solve for b. Okay, so I get, when I solve for b, you multiply by 2 over root 3, so you get b is equal to 2h over root 3. And we just did a problem like this. Can we have a square root on the bottom? No, we can't. So I'm going to multiply the bottom and the top by a root 3, because that's what's on the bottom. And I'm left with 2h root 3 over 3. That is what b is equal to. b is equal to that. Now I can plug this whole thing in to this b, because I don't want any b's in the answer. So my final answer becomes a equals 1/2 times 2h root 3 over 3 times another h. And when I simplify all this, the 2's cancel, and the h's become h squared. So my final answer is a is equal to h squared root 3 over 3. And again, you just have to be careful with what you're plugging in and what you're dealing with. For instance, this one here, we had to convert our original equation, solve for b, and then you need to know that the area of a triangle is 1/2 base times height. Okay, those are the only problems that you had to do today for the notes. We'll work on these again in class, and you guys can work in groups and ask questions then. Alright, I will see you guys later.